Hi everyone, today we're going to look at how we show relatedness or how species are related based on phylogenetic trees. So showing relatedness, so we can show relationship between species and larger taxonomic groups visually using diagrams called phylogenic trees or cladograms. Phylogenic trees are a type of diagram which reflects the evolutionary relationship of organisms based on the distance from a common ancestor. So these diagrams are often constructed on the basis of biochemical evidence, where we use DNA sequences that we've already spoken about, or RNA sequences or proteins. However, we can also use structural and physiological features to help us with these drawings as well. So these can also be referred to as evolutionary trees. They're branching diagrams that show an inferred evolutionary relationship. So there are different ways that we can draw these phylogenetic trees. So we can draw them in a V shape with arms extending off. We can draw them as a table, I suppose, like vertically. We can draw them horizontally. The most important thing is that at each branch or each point of divergence between one group and another, this shows the divergence from a common ancestor. Okay. Let's unpack a little bit more about phylogenetic trees. So the root of a phylogenetic tree is where it starts. So this is where we're looking at divergence from a common ancestor. The nodes indicate common ancestors or divergence points, as I like to call them. Point of divergence. Okay. The branch length conveys important information about a phylogenetic tree. It shows an amount of time since there has been a change or a divergence from a common ancestor. Okay, so outgroups and ingroups, I suppose. So we're just going to have a little bit more of a look at the vocabulary of these phylogenetic trees. Okay, so we've looked at the node, which is where we've got a hypothetical common ancestor. We've looked at the root, which is the relationship in the context of time. Time progresses as we go further away from that root or that initial divergence point. Okay, so outgroups are important. So the outgroups are the ones that sort of the branches with the different names of the organisms or the different indicators. They are important to compare as they allow us to be able to understand where we are in comparison to other organisms. And in-groups are those we're looking at that are not part of outgroups. Okay, so in-groups are ones that are sort of further in, where we've got those little nodes, those common ancestors. Okay. Sometimes we might have little trees which don't lead anywhere or lead to an extinct organism. So these are called extinct lineages. Okay. Phylogenetic trees sometimes can also be called cladograms. So there's a few differences. So a clade or a clade is a section of the phylogenetic tree which is showing an evolutionary relationship between a set of organisms. A phylogenetic group, okay, has the ancestor and some of its descendants. So you can see that you've got the original one, whereas in the clade, you're just looking at a group of organisms, a little bit of a cutout. And a monophyletic group is another type of clade where you're looking at the ancestors of all the descendants. So you're looking at different lineages or different sections within the tree. Okay, so as I said before, there's a slight difference. So cladograms also show relationships, but they're more focused on features rather than biochemistry. So cladogram is another way that we can group organisms based on similarities arising from their evolutionary relationship. So organisms are organized into groups called clades based on the basis of the presence of derived characteristics like physical features that they share. These features must be novel and have not had the appearance in earlier ancestors. So though we don't look at the difference between divergent and convergent evolution in our study design, when we're looking at divergent evolution or movement from a common ancestor into different ancestral groups, that's when we're looking sort of at a phylogenetic tree. Whereas when we look at cladograms, we're looking a lot at similar characteristics that have arisen over time, but those characteristics may not be to do with the common ancestor. Rather, it might be just to do with the fact that those organisms have got similar environmental pressures. As we said before, there's a couple of special things for cladograms. So all groups appear at an endpoint, regardless of whether they're living or extinct. This contrasts with a phylogenetic tree because it will also show extinct species at their relative positions on a time scale. The length of branches on a cladogram does not convey information about the evolutionary time periods, whereas on a phylogenetic tree, it does. You can make a cladogram. Okay, so this is just a little bit of a table which shows the characteristics of some organisms, whether they appear and whether they don't. The person has then used this information to draw a phylogenetic tree. To draw a cladogram. Okay, so again, this is based simply on the fact that these organisms have got similarities and differences.